You think the Sun is big. It holds 99.8% of all the mass in our solar system. You could fit 1 million Earths inside it. But in the grand scheme of the universe, our Sun isn't a heavyweight champion. It is a grain of sand. If you replaced our Sun with the largest star we know, it wouldn't just touch the Earth, it would swallow Jupiter. Today, we are stepping into the ring to compare our home star against the true monsters of the Milky Way. To understand how small we are, we first have to understand what we're starting with. Astronomers classify our Sun as a G-type main sequence star, or more commonly, a yellow dwarf. It feels massive to us because we're standing right next to it. It has a diameter of roughly 865,000 miles. You could line up 109 Earths across its face. Inside, you could fit 1.3 million Earths. It is a perfect sphere of superheated plasma burning hydrogen into helium at 15 million degrees Celsius in its core. It is the engine that drives all life on our planet. But here's the reality check. The Sun is average. In fact, it's arguably on the small side. The universe is populated by monsters that defy our ability to comprehend scale. We are going to leave our safe little solar neighborhood and travel deeper into the galaxy to meet 3 specific challengers: the brightest, the giant, and the titan. This isn't just a size comparison, it's a look at the life and death of stars. Welcome to Space Facts. Let's measure the monsters. First up is the brightest star in our night sky, Sirius. If you look south on a winter night, it's the blue-white diamond glowing in the constellation Canis Major. That's why we call it the dog star. It's located just 8.6 light-years away, making it one of our closest neighbors. But Sirius isn't like the Sun. The Sun is a stable, middle-aged star. Sirius is young, hot, and aggressive. It's an A-type star, meaning it burns its fuel much faster and fiercer. If you put them side by side, Sirius has a radius 1.7 times that of the Sun. That might not sound like a huge jump, but in astrophysics, a small increase in size usually means a massive increase in power. Because Sirius is bigger and hotter, burning at nearly 10,000 Kelvin compared to the Sun's 5,500 degrees, it's 25 times more luminous. If you magically swapped our Sun for Sirius, Earth would be sterilized in minutes. The oceans would boil into steam, and the intense ultraviolet radiation would strip away our atmosphere, leaving a scorched rock behind. There's another secret here, too. Sirius isn't alone. It's a binary system. Hidden in the glare of the big star is a tiny companion called Sirius B. It's a white dwarf, the dead corpse of a star that was once massive. It packs the mass of the Sun into a ball the size of Earth. So when you look at Sirius, you're seeing a young, powerful star dancing with a dead, dense ghost. But even Sirius is just a spark compared to what comes next. Now we jump to the heavyweight division. Meet Pollux. Pollux is the brightest star in the constellation Gemini, the twins, located about 34 light-years away. This star tells us a scary story about our own future. Pollux is an orange giant, or K-type. It wasn't always a giant. Billions of years ago, Pollux looked a lot like our Sun. But eventually, it ran out of hydrogen fuel in its core. When that happens, the core collapses, gets hotter, and the outer layers of the star puff out like a marshmallow in the microwave. Pollux is currently roughly 9 times wider than the Sun. To visualize this, if the Sun was a standard tennis ball, Pollux would be a large beach ball. It's glowing with a cooler orange light because its energy is spread out over such a massive surface area. Here's where it gets interesting. Pollux has a planet. Astronomers discovered a gas giant called the Theseus orbiting it. Imagine standing on a moon orbiting that planet. You wouldn't see a small yellow sun, you would see a massive, angry orange eye filling a huge chunk of the sky, bathing the world in a twilight glow. This is exactly what will happen to our Sun in about 5 billion years. It will swell up, consume Mercury and Venus, and turn Earth into a cinder. Pollux isn't just a star, it's a crystal ball showing us our own demise. You're watching Space Facts, where we scale the unscalable. If you want to feel small in the best way possible, and you want to know what else is hiding in the dark, make sure to subscribe and hit the bell. Now, let's unleash the monster. Forget the tennis ball, forget the beach ball. We are now entering the realm of the red hypergiants. Meet UY Scuti. Located near the center of the Milky Way, about 9,500 light-years away in the Scutum constellation, this star is a monster that defies logic. It's estimated to be roughly 1,700 times wider than the Sun. Numbers like 1,700 are hard to visualize, so let's use a travel analogy. Imagine you're in a commercial Boeing 747 cruising at 900 kilometers per hour. If you flew that plane along the equator of our Sun, the trip would take about 7 months to complete one lap. That's a long flight. Now, imagine you fly that same plane around UY Scuti. You would be flying for 1,200 years. Generations of pilots would be born, live their entire lives, and die in the cockpit before the plane completed a single circle around the star. The Roman Empire didn't last as long as it takes to fly around this thing. Let's place it in our solar system. If you dropped UY Scuti where the Sun is, its surface wouldn't just swallow Earth. It wouldn't stop at Mars. It would extend out past the asteroid belt, past Jupiter, and nearly touch the orbit of Saturn. Saturn, a planet that is currently freezing cold, would be skimming the surface of a star that takes up the entire sky. Inside this single star, you could fit 5 billion suns. But UY Scuti is also a ghost. It's a red hypergiant, which means it's incredibly diffuse. Our Sun is dense, but UY Scuti has blown its outer layers out so far that the surface is basically a hot vacuum. If you were floating at the edge of UY Scuti, you might not even realize you were inside a star. It would feel like being in a hot red fog that goes on forever. It's losing mass constantly, coughing up dust and gas that will eventually form new solar systems. It's dying, and soon, in cosmic terms, it will detonate as a supernova, leaving behind a black hole. When you look up at the sky tonight, remember this. Our Sun gives us life, but it's a cosmic speck. We live next to a yellow dwarf in a quiet suburb of the galaxy. Out there in the dark, there are things like Pollux and UY Scuti, titans that are so massive they make our entire solar system look like a rounding error. The universe isn't just big, it's aggressively, terrifyingly huge. If this size comparison made you feel tiny, hit that like button. Subscribe to Space Facts for more cosmic battles.